Picture a wide glass jar on a table filled to the brim with coins. Nobody has counted them. Now, imagine a long line of people walking past that jar, one after another, each pausing to write down a single guess. One person says a few hundred, another says thousands. Someone squints and guesses far too low, and the person behind them guesses wildly too high. Not one of them knows the real number. Not one of them is right. But here is the quiet wonder. If you gather all those wrong guesses together and find the middle of them, the answer that sits at their center often lands astonishingly close to the truth. The crowd, made of people who are each mistaken, somehow knows. That gentle miracle sits at the heart of what we call statistics. It is the art of listening to many small, imperfect voices and hearing underneath them something steady and true. Tonight we are going to walk slowly through that art, where it came from hundreds of years ago in dusty tables of births and deaths, how it learned to measure chance and averages and the way things spread, why it still quietly shapes almost every part of the life you are resting in right now. You do not need to remember any of it. There will be no test in the morning. You are allowed to drift off long before we reach the end, and the numbers will keep each other company without you. Let your breathing slow. Let the day you had settle behind you like sediment sinking through still water. Let's begin Chapter 1. Long before anyone spoke of statistics, people simply counted. A shepherd counted sheep at dusk, moving pebbles from one pouch to another. A king counted soldiers and grain and the coins in his treasury. To count was to hold the world still for a moment, to say, here is how much there is. The very word statistics comes from an old idea about the state, about the sort of knowledge a government keeps. Numbers about people gathered so that those in charge might understand the size and shape of what they govern. For a long time, that was all it was, counting and writing the counts down. Then, in the middle of the 17th century, in a London crowded and coal-smoked and often visited by plague, something new began. Each week the city printed small pamphlets called the Bills of Mortality. They listed how many people had died and, roughly, of what. A certain number of fevers, a certain number of a sickness they called consumption, a certain number in the bad years of plague. People bought these bills nervously, the way you might glance at a weather warning, wondering whether it was time to leave the city for the countryside. A shopkeeper named John Grount did something with those bills that no one had quite done before. He gathered years and years of them together, and instead of reading each week as its own small piece of news, he looked across all of them at once. He added them up. He arranged them. He asked what the whole pile of numbers, taken together, was trying to say. And slowly, patterns rose up out of the noise. Patterns no single week could ever have shown him. He noticed, for instance, that more boys were born than girls, year after year, steadily, in a way that felt less like accident and more like some quiet rule of the world. He noticed that many deaths came in the earliest years of life, that a great share of children did not reach adulthood, a sorrow that everyone felt in their own family, but no one had ever seen laid out as a whole. He even tried to estimate how many people lived in London, working outward from births and deaths, reasoning his way toward a number no census had given him. He was, in a sense, guessing, but guessing carefully, letting the numbers guide the guess. What John Grount had stumbled into was the idea that a crowd of numbers can behave more lawfully than any single number within it. One death is a mystery, sudden and personal and impossible to predict. 10,000 deaths, gathered and sorted, begin to show regularities, rhythms, proportions that hold from one year to the next. The individual stays unknowable. The mass becomes almost readable. This is the strange gift at the center of everything we will talk about tonight. And it is worth letting it settle in your mind as gently as it first settled into his. You can rest here for a moment. There is nothing to solve. Just imagine those old paper bills stacked on a wooden desk by candlelight, and a quiet man turning them over page after page, seeing something no one else had seen. For a long while, this new way of thinking had no proper name and no real home. It lived in the margins of other subjects, borrowed by astronomers measuring stars, by merchants weighing risk, by governments taking their careful counts. It was less a science than a habit, a way of paying attention. But the habit spread because it worked. Wherever people gathered enough numbers and looked at them as a whole, the world seemed to whisper back its hidden order. Nearly 2 centuries after John Grount, a woman named Florence Nightingale carried this same habit into the wards of a military hospital. You may know her as a nurse, moving between the beds at night with a lamp. She was that. But she was also, quietly, one of the finest number gatherers of her age. In the hospitals where she worked, she counted deaths with the same clean, patient devotion John Grount had shown, and she saw something that troubled her deeply. Far more soldiers were dying of illness born from filth and crowding than from any wound taken in battle. Knowing it was one thing, making the men in charge believe it was another. So she drew the numbers as pictures, shapes colored and arranged so that anyone glancing at them could feel the truth at once, without following a single column of figures. The great wedge of preventable death loomed over the thin sliver of death from battle, and no one who saw it could look away. She had understood something we sometimes forget even now. A number can be true and still go unheard. Sometimes you have to give it a shape before it can speak. And so statistics grew up alongside compassion, not apart from it. It was born from people trying to understand suffering well enough to lessen it, from counting the dead in order to protect the living. There is something tender in that origin, something worth remembering when numbers feel cold to you. At the very beginning, they were a way of caring at a scale too large for any single heart to hold. By now you may feel the pattern of these early years. First, someone simply counts. Then someone gathers many counts together. Then, in that gathering, an order appears that no one had arranged, and a person of unusual patience notices it, and the world is a little better understood than it was the day before. This is how the whole subject moves. Again and again, across the centuries we will wander through tonight, not in sudden leaps, but in slow acts of attention. Rest with that idea, if you like. You do not have to carry it. Let your shoulders loosen. Let the pillow take the weight of your head. The counting has been going on for a very long time, and it will go on gently without any effort from you tonight. We began with a jar of coins and a crowd of wrong guesses, and we have arrived at old paper bills and a lamp carried through a hospital in the dark. In both, the same quiet truth is at work. Many small things, gathered with care, reveal something none of them could show alone. In the hours ahead, we will follow that truth as it deepens. As people learn not only to count the world, but to measure its very uncertainty, to put a number on chance itself. But before anyone could measure chance, they had to answer a simpler and softer question. When you have a whole heap of numbers in front of you, all of them a little different from one another, where exactly is the middle of them? And what does that middle really mean? That gentle question is where we will settle next, and there is no hurry at all in getting there. Chapter 2. Suppose you gather the heights of everyone in a small village and write them down, one below another. No two are quite the same. Some people stand tall, some are slight, most fall somewhere in the comfortable middle. If someone asks you how tall the people of this village are, you cannot read out the whole list. They would be asleep before you finished, which tonight would be no bad thing. But it would not answer the question. What they want is a single number that stands in for the many. They want the average. The average, in its most familiar form, is a simple and rather beautiful idea. You add all the heights together into one great sum, and then you share that sum out equally among everyone, as if you could melt all the people down and pour them back into molds of exactly the same size. The height each person would have, if every scrap of height were divided evenly, is the average. It is the level the water would settle to if you poured all the differences into one flat pool. There is something quietly reassuring about it. The average does not care who is tallest or who is smallest. It gives every number an equal share of its attention. It smooths the jagged edges of a crowd into one calm figure you can hold in your mind. And for a long time, this smoothing felt almost magical, as if the average revealed some ideal hidden inside the mess of real people. In the early part of the 19th century, a Belgian named Adolphe Quetelet fell in love with exactly that idea. He was an astronomer by training, used to the way many slightly different measurements of a single star could be averaged into one trustworthy position. And he wondered what would happen if he turned that same tool away from the sky and toward human beings. So he began collecting measurements of people, their heights, the breadth of their chests, their weights, the ages at which they married or died. He gathered these numbers by the thousand and took their averages, and out of that arithmetic he dreamed up a figure he called the average man. This average man was not any real person. He was a kind of gentle ghost assembled from everyone at once, standing at the exact center of humanity. His height was the average height. His weight was the average weight. Everything about him was the middle of everyone. Quetelet came to see this imagined figure almost as an ideal, the shape a person would take if nature were not always nudging each of us a little to one side or the other. Real people, in his view, were scattered around this average man, like arrows around a target's center, each of us a small departure from the type. you can feel, even now, why this idea was so seductive. It suggests that beneath all our messy variety, there is a plan, a template, and that the average lets us glimpse it. And yet, if you hold the thought a little longer in the quiet of the evening, you may sense its danger too. The average man is nobody. No one has exactly the average height, and the average weight, and the average everything else, all at once. He is a summary, not a soul. To mistake him for a real person, or worse, for the person everyone ought to be, is to forget that the whole reason we needed an average was that people differ. Let that be a soft thought rather than a worry. You do not have to resolve it tonight. Just notice how a single number, meant only to help us hold a crowd in mind, can quietly begin to feel like a truth about each one of us. Statistics has been walking that line ever since, between the helpful summary and the misleading ideal. There is more than one kind of middle, and it is worth knowing them gently because they do not always agree. The average we have been describing, the one you get by adding everything up and sharing it out, is only one way to find a center. There is another, called the middle value, the one you land on if you line every number up in order from smallest to largest and walk to the very center of the line. Half of everyone stands below that person, half above. In a calm and even crowd, this middle value and the shared out average sit almost on top of each other, close as two sleepers breathing in time. But they can pull apart, and when they do, they tell a story. Imagine a small town where nearly everyone earns a modest, ordinary living, and then one day, a single immensely wealthy person moves in. The middle value of the town's income barely stirs because the person standing at the center of the line has not changed. But the average leaps upward because that one great fortune added into the sum and shared out among everyone lifts the whole figure as if by illusion. On paper, the town looks suddenly prosperous. In their kitchens, nothing has changed. This is why, when someone tells you the average of something, it is worth wondering quietly which kind of middle they mean and what the numbers around it look like. There is even a third sort of center, humbler than the others, called the most common value, the one that simply appears more often than any other. If you asked what size of shoe a shop sells most, you would not add up all the sizes and divide. You would just notice which size walks out the door most often. Each of these three middles answers a slightly different question, and part of the quiet craft of statistics is knowing which one to reach for. None of this needs to keep you awake. If your eyes are growing heavy, let them close. The averages will still be here, patient as ever, doing their gentle work of standing in for the many. There is nothing you must hold on to. What matters as we drift onward is this. The average was our first real tool for taming a crowd of numbers, for turning a bewildering list into a single point we can rest our attention on. It gave us a center. But a center, by itself, leaves out something enormous, something you already know in your bones. It says nothing about how far the numbers wander from that middle. Two villages can share the very same average height, and yet in one everyone is nearly identical, while in the other there are giants, and there are the very small, and the calm average hides all of it. So the next question follows as naturally as breath follows breath. Not only where is the middle, but how spread out are things around it? How much do they vary? That question opens a whole new room in the house of statistics, and we will step softly into it now. Chapter 3. Think of two archers standing side by side, each shooting many arrows at the same target. When you gather the arrows and find their center, both archers turn out to have the same average. Their aim, measured that way, is identical. But one archer's arrows are clustered tightly, almost kissing one another around the middle, while the others are flung wide, some near the edge of the target, some barely on it at all. The average cannot tell these two apart, and yet anyone watching would say they are utterly different archers. The thing that separates them is not where their arrows center, but how far those arrows wander. That wandering has a name. We call it spread or variation, and it is every bit as important as the middle. For a long time, spread was the quiet, overlooked companion of the average. People were so pleased to have found a center that they forgot to ask how far things strayed from it. But the world is made of straying. No two leaves on a tree are the same size. No 2 days are the same length of daylight. No 2 loaves from the same oven weigh exactly alike. Variation is not a flaw in the world's design. It is the texture of the world itself. And to understand anything truly, you have to learn to measure not just its typical value, but the size of its restlessness. Imagine you want to describe how spread out a set of numbers is. Your first instinct might be to see how far each number sits from the average, and then take the average of those distances. That instinct is a good one, and it leads to a gentle measure, sometimes called the typical distance from the middle. If the numbers huddle close, this distance is small. If they range far and wide, it is large. 2 towns might share an average income, but if one has a small spread, life there is fairly even. While a large spread means great wealth and great want living in the same place, the spread tells you the story the average leaves out. The most widely used measure of spread grew from this same idea, though it takes a slightly roundabout path to get there. Rather than working directly with the distances from the middle, it squares them first, which is a way of making every distance count as a positive amount and of paying extra attention to the numbers that stray farther. Then it averages those squared distances, and finally, to undo the squaring, it takes the square root at the end. The number you are left with is called the standard deviation, and though its name sounds severe, its meaning is soft and intuitive. It is, roughly, how far the numbers typically sit from their own center. A small standard deviation is a tight cluster of arrows. A large one is a scatter. You do not need to follow that arithmetic tonight, not even a little. Let the words wash over you the way the sound of rain does when you are warm and half asleep. The only thing worth carrying is the picture. A middle and a cloud of numbers gathered around it, sometimes tight, sometimes loose. That is all the standard deviation is trying to say. The man who did more than almost anyone to make variation itself a subject worthy of study was an Englishman named Francis Galton, working in the second half of the 19th century. He was a restless, endlessly curious person, forever measuring things that others thought too ordinary to to bother with. He measured the heights of parents and their grown children. He measured the sizes of sweet pea seeds passed from one generation to the next. He set up a little booth at an exhibition where, for a small coin, people could have their strength and their senses measured, and he gathered their numbers by the thousand. Where others saw only messy differences between people, Galton saw a subject with laws of its own. What captured him was not the average by itself, but the way things scattered around it, and whether that scatter followed rules. He began to suspect that variation was not shapeless at all. Gather enough measurements of almost anything that arises from many small causes, and the spread tends to fall into a particular, graceful form. Most values crowd near the middle. Fewer lie a little way out on either side. Fewer still reach the far edges, and hardly any go to the extremes. The scatter is not random in the sense of being lawless. It has a shape, the same shape, appearing again and again, whether he was measuring seeds, or people, or errors in a careful reading. That recurring shape is one of the loveliest things in all of statistics, and we will give it a whole stretch of the night to itself very soon. For now, simply notice what Galton had done. He had taken variation, the thing everyone treated as noise, to be averaged away, and he had made it the star of the show. He had said, in effect, that the way things differ is itself deeply patterned, and that if you study the spread with the same devotion others gave the middle, the world opens up in new ways. There is a quiet kindness hidden in this idea, and it is worth resting on as you lie there. To study variation is to take difference seriously. It is to say that the tall and the small, the early and the late, the ones near the center and the ones out at the edges, all belong to the same gentle curve. All are part of the same natural scatter. Nobody is a mistake in a world governed by spread. Everyone is simply somewhere on the cloud. If your thoughts have begun to loosen and drift, that is exactly right. You are allowed to stop following now and let the ideas continue on their own. Nothing here depends on your attention. The numbers keep their shape whether or not anyone is watching, and so will your rest. We now have two great tools resting in our hands. The middle, which tells us where a crowd of numbers gathers, and the spread, which tells us how loosely or tightly they gather there. Together, these two simple ideas can describe an astonishing range of things, from the heights in a village, to the errors in a measurement, to the weights of loaves from an oven. But Galton's discovery hints at something larger still, that the spread so often falls into one particular, recurring shape, as if the world had a favorite way of scattering. In the hours ahead, we will meet that shape face to face. The famous curve that rises in the middle and falls away so gently on both sides, and we will see why it appears in so many places that people once thought it must be a law of nature itself. Chapter 4. Let us finally look at the curve itself. Imagine you pour a large sack of fine sand slowly onto a flat table, always from the same point above the center. The grains do not stack in a neat tower. They tumble outward as they land, most settling near the middle, a good many a little way off, only a scattered few reaching far to the edges. When the sack is empty, you step back and see a soft, rounded heap, high and full, in the center, sloping away gently on every side until it fades into nothing. That heap, that shape, is very nearly the most important form in all of statistics. People call it the bell curve, for it looks a little like the silhouette of a bell, and it appears so often that its more formal name is simply the normal curve, as if to say, this is the normal way for the world to scatter. Why should so many different things settle into this one shape? The heights of grown people tend to fall along it. The small errors an astronomer makes in measuring the same star over and over fall along it. The sizes of Galton sweet pea seeds fall along it. Even the total you get from rolling many dice at once and adding them up will pile itself into this same soft hill. It is as though nature, given enough small independent nudges pulling in every direction, keeps returning to the same gentle form, and there lies the secret of it. The bell curve tends to appear whenever the thing you are measuring is the sum of many small, unrelated influences, no one of which dominates the others. Your height comes from countless tiny contributions, from many separate scraps of inheritance, from nourishment, from the quiet accidents of growing up, each pushing you a little taller or a little shorter. Add together enough of these small independent pushes, and the pluses and minuses mostly cancel, leaving most people near the middle. Only when a great many pushes happen to point the same way do you land far out toward the edges, and that is rare, which is exactly why the tall extremes and the short extremes are so thinly populated. The curve is what the sum of many small chances looks like. The first person to glimpse this curve in a clear mathematical way was a Frenchman living in exile in London named Abraham de Moivre, working in the early part of the 18th century. He was a gifted mathematician who never found a secure position, and he made part of his living advising gamblers and merchants on questions of chance. While studying the tosses of coins, he noticed that as the number of tosses grew very large, the spread of possible outcomes drew itself into a smooth, bell-shaped form. He had found the curve hiding inside the humble coin. It is a little poignant that so profound a discovery came to a man scraping together a living at the edges of other people's games. But the world is often careless about where it hides its treasures. Nearly a century later, a German named Carl Friedrich Gauss, one of the most gifted mathematicians who has ever lived, met the same curve from an entirely different direction. He was not studying coins. He was studying the heavens, trying to pin down the true positions of stars and the paths of newly found bodies wandering across the sky. Every measurement an astronomer makes carries small errors, a slight misreading here, a tremor of the instrument there. Gauss asked how those errors ought to be distributed if you took the same measurement many times, and the answer that fell out of his reasoning was the very same bell-shaped curve. Because of his deep work on it, the curve is often named after him, though he would have been the first to say he had only rediscovered something woven deep into the fabric of chance. Two men, then, one poring over coins in a London coffee house, one gazing at the night sky in Germany, arriving at the same shape from opposite ends of human life. That is a large part of why the curve came to feel almost sacred to the people who studied it. It seemed to be waiting for them everywhere they looked, a hidden order beneath games and stars alike. For a while, some thought it must be a universal law that nearly everything in nature would bow to it, if only you measured enough, ret, for a breath here. There is a genuine beauty in this, and it asks nothing of you but a moment's wonder. The same soft hill of sand, rising in your kitchen, hiding in a handful of dice, sketched across the sky in the trembling of a telescope. Let your body sink a little deeper into the bed as you picture it. The curve does not hurry. It simply rises and falls the same way, wherever many small chances gather. The curve carries one more quiet gift, and it is what makes it so useful. Once you know that something follows this shape, and once you know its middle and its spread, you know almost everything about it. The two tools we gathered earlier, the center and the standard deviation, are exactly the two numbers that pin the bell curve in place. The center tells you where the peak sits. The spread tells you how wide and low, or how tall and narrow, the hill will be. From those two numbers alone, you can say how much of the crowd lies close to the middle, how much wanders one step out, how rare it is to find someone far into the thin tails at the edges. A great sprawling mass of measurements collapses into two friendly numbers and a shape you can see with your eyes closed. It is worth being gently honest, though, before we move on. The bell curve is common, but it is not everything. Some things in the world do not follow it at all. Wealth, for instance, spreads in a far more lopsided way, with most people gathered low, and a long, thin tail of great fortunes stretching far to one side, nothing like the balanced hill. The sizes of cities, the frequency of words in a language, the damage done by rare disasters, all of these follow other shapes entirely. Part of the maturing of statistics was learning that the beloved curve, for all its beauty, was one member of a whole family of forms, each suited to a different kind of world. To assume everything is a bell curve is a gentle error and a common one, and it is good to hold the curve with affection, but not with blind faith. You do not have to keep any of this. If the words are beginning to blur together, let them. The shape will hold itself. We have now met the world's favorite scatter, and we have seen that it lives inside the tosses of coins and the small errors of careful people. But notice what keeps appearing at the root of it: chance, coins, dice, errors, the countless tiny accidents that shape a height. Underneath the curve lies the question of chance itself, of what it even means to say that something is likely or unlikely. And that question, strange to say, is younger than you might think. For most of human history, no one had any real mathematics of chance at all. How that finally changed, and the unlikely friendship that changed it, is where we turn next. Chapter 5. Here is something strange to consider as you lie there in the dark. For thousands of years, human beings rolled dice, drew lots, and wagered on games of chance, and yet no one had worked out the mathematics of it. Ancient people gambled with the same little bones we would recognize as dice. They bet on the outcomes. They surely had hunches about which results came up more often. But the idea that you could sit down and calculate exactly how likely a given outcome was, that idea took an astonishingly long time to arrive. Chance was treated as the province of the gods or of fate, something you prayed to rather than something you could reason about. To measure luck seemed almost a contradiction. There were a few early stirrings. In the 16th century, an Italian named Girolamo Cardano, a physician and a restless gambler, wrote a small book about games of chance, working out some of the earliest known calculations of how likely certain dice throws were. He understood, for instance, that some totals come up more often than others because there are more ways to reach them. But his little book was not published until long after his death, and his insights sat unread for many years. The mathematics of chance was waiting for the right moment and the right pair of minds. That moment came in the middle of the 17th century, and it came, fittingly, from a gambling problem. A French nobleman who enjoyed games of chance was puzzled by a question about how to fairly divide the stakes when a game is interrupted before it is finished. Suppose two players are partway through a series of rounds. One is ahead, and for some reason they must stop and go home. How should they split the pot fairly, given where things stood? It seems a small question, almost a parlor puzzle. But answering it properly turned out to require inventing an entire way of thinking. The nobleman brought the puzzle to a brilliant and devout French thinker named Blaise Pascal, and Pascal, rather than solving it alone, began writing letters about it to another towering French mathematician, a quiet judge and part-time genius named Pierre de Fermat. Back and forth their letters went, through the slow post of the age, each turning the problem over, each proposing ideas, correcting the other, refining the reasoning. And in that gentle correspondence between two men who never worked in the same room, the mathematics of probability was born. What they realized was deceptively simple, and it is the seed of everything. To judge the fairness of the interrupted game, you should not look only at who is ahead right now. You should look forward at all the ways the game could still unfold from this point, count them, and see in what fraction of those possible futures each player would win. The stakes should be divided according to those fractions, according to each player's share of the possible futures. In doing this, they had defined, for the first time with real rigor, what it means to say something has a certain chance. A probability, in their hands, became a way of counting possible worlds. If a fair die can land 6 ways, and only one of them shows a single dot, then the chance of a single dot is 1 in 6, because it is one favorable outcome among 6 equally possible ones. Sit with that quietly for a moment, because it is one of those ideas that feels obvious only after someone has thought of it. To find a probability, you imagine all the equally likely things that could happen, and you ask what fraction of them are the ones you care about. The chance of drawing a red card from a shuffled deck is 1/2, because half the cards are red. The chance of a tossed coin showing heads is 1/2, because there are 2 equally likely faces, and one of them is heads. Simple, once seen, invisible for millennia until 2 friends traded letters about a gambler's puzzle. There is a lovely gentleness in the origin of this. The mathematics that now guides insurance and medicine and the safety of the bridges you cross began not in fear or in crisis, but in curiosity and play, in 2 thoughtful people enjoying a hard problem together. So much of what we will speak of tonight has that quality. It grew from people delighting in the world's puzzles, following their curiosity, the way a stream follows the slope of the land, patiently wherever it led. You can let your attention soften now if it wishes to. None of this is a task. Picture the two letters crossing France on horseback, the ideas ripening in the days between one reply and the next. There is no need to hurry a good thought, and there is no need to hurry towards sleep either. Both arrive in their own time. Once you have this way of counting possible outcomes, a whole landscape opens before you. You can ask not just about a single roll, but about many. What is the chance of rolling 2 6s in a row? You reason that each roll has a chance of 1 in 6, and that to get both you must pass through both narrow gates. So the chances multiply, and 2 6s together come up only 1 time in 36. What is the chance of getting at least 1 6 in several rolls? That takes a little more care, but the same principle guides you. You count the possible worlds, you find the fraction you care about, and the fog of luck resolves into something you can actually hold. Gamblers had felt these things in their bones for ages. Now, for the first time, they could be known. And yet, even as probability gave people this new power, it whispered a caution that we still need to hear. Knowing the chance of something does not tell you what will happen on any single try. The coin that is fair, that truly has an even chance of each face, can still come up heads 5 times in a row. The die that so rarely shows its single dot can show it twice in a moment. Probability does not promise to tame the next event. It speaks not about the single case, but about the long run, about the pattern that emerges when a thing is repeated again and again and again. On any one night, anything can happen. It is only across the great sweep of many nights that the numbers keep their word. That distinction between the wildness of the single try and the steadiness of the long run is one of the deepest and most soothing ideas in the whole subject. It deserves its own quiet stretch of the night, because a man once proved, with real mathematical care, exactly why the long run behaves so well, why the storm of individual chance settles over time into something as calm and dependable as still water. That proof, and the patient man behind it, is where we drift to next. Chapter 6. Take a single coin and toss it just a few times. You might get 3 heads and 1 tail, or all tails, or some other lopsided little run. Nothing about those first few tosses looks like the calm 1/2 we say a fair coin should give. The early tosses are jittery, unpredictable, full of small surprises. If you judged the coin only by them, you might think it was crooked, but keep tossing. Toss it 100 times, then 1,000, then 10,000, keeping a running tally of how often heads comes up. Something quietly wonderful happens. The fraction of heads, wild and swinging at first, begins to settle. It drifts closer and closer to 1/2, and the more you toss, the less it strays. The chaos of the single toss dissolves into a smooth and dependable rate. This is the law of large numbers, and it is one of the gentlest and most reassuring truths in all of mathematics. It says that while any single event may do anything at all, the average of many events grows steady and predictable. The individual stays free and surprising. The mass becomes calm. It is the very thing John Grount had glimpsed in his stacks of London death records without being able to prove it. It is the reason the crowd of wrong guesses around that jar of coins could hold a right answer at its center. And in the closing years of the 17th century, a Swiss mathematician finally proved with full rigor that it must be so. His name was Jacob Bernoulli, one of a remarkable family that produced mathematician after mathematician across the generations. He worked on this problem for many years, calling it, with real affection, his golden theorem, because he sensed how deep and how beautiful it was. What he proved was this: if a thing has a true underlying chance of happening, then the more times you repeat the trial, the more nearly certain you become that the fraction you actually observe will sit close to that true chance. Not exactly on it, perhaps, but as close as you like, if only you are willing to repeat the trial enough times. The long run does not merely tend toward the truth. It can be made to hug the truth as tightly as you wish. Let that settle over you like a warm blanket, because there is real comfort in it. The world, at the level of the single moment, is unruly. You cannot know how the next coin will land, or the next roll, or the next small accident of a day. But underneath that unruliness, there is a floor, a stable rate that the chaos is always quietly settling toward. The uncertainty does not go away. It organizes itself. It becomes something you can plan around, something you can trust, not for the next event, but for the great river of events taken together. You can feel this law working all around you, once you know to look. An insurance company cannot possibly know which particular house will suffer a fire this year, or which particular person will fall ill. Each of those single events is as unpredictable as a single coin toss. And yet the company can plan its whole future with real confidence, because across many thousands of houses and many thousands of people, the fraction that come to harm is remarkably steady from year to year. The law of large numbers turns a mass of individual uncertainties into a collective near certainty. It is why the very idea of insurance can exist at all. Why strangers can quietly pool their small risks and so protect one another from ruin. There is something almost tender in that. A whole system of mutual care resting on the steadiness of the long run. The same law is what a casino leans on, though to a colder purpose. Every game is arranged, so the house holds a tiny edge, a chance tilted just barely in its favor. On any single spin or hand, a player may win, and win big, and walk away, delighted. The house does not mind, and cannot be hurt by it, because it is not playing a single hand. It is playing millions of them, and across those millions, the law of large numbers guarantees that its small edge will express itself with almost perfect reliability. The gambler experiences the wild single event. The house lives in the calm long run. That is, the whole quiet secret of the place. Ret here a while. There is nothing to work out. Just let the image of the settling coin stay with you. That jittery fraction, gradually smoothing toward one half, the way a rocking boat gradually steadies on calming water. If your thoughts want to drift off along with it, let them. Nothing tonight needs finishing. It is worth pausing to clear away one common confusion gently, because it trips up almost everyone at some point. The law of large numbers does not mean that the coin somehow keeps score, that a long run of heads must soon be balanced by a run of tails to even things out. The coin has no memory. It does not know or care what it did a moment ago. Each toss is fresh and independent, still 1/2 for heads. No matter how many heads came before, the fraction settles toward 1/2, not because past results are corrected, but because, as the tosses pile up, any early streak is simply diluted, swallowed by the sheer number of ordinary tosses that follow. The imbalance is not repaid. It is outnumbered. That is a softer and truer picture than the idea of luck balancing its books, and it is worth holding on to. So, the wildness of the single case and the calm of the long run are not enemies. They are two faces of the same coin, quite literally. Chance is free at the small scale precisely so that it can be dependable at the large one. And this is why statistics can be both humble and far-reaching at once. It never pretends to tell you what the next moment holds. It offers instead the deeper and more useful gift of telling you, with real confidence, the shape of the many moments taken together. We have now watched averages tame a crowd of numbers, spread describe how they scatter, the bell curve reveal a favorite shape, probability put a measure on chance, and the law of large numbers promise that chance grows steady over time. These are the deep foundations laid down over centuries by patient and curious people. From here, the subject begins to turn outward, towards stranger and more surprising truths, toward the odd ways that measurements behave when you follow them across generations. One of the first of those surprises was noticed by a man we have already met, gazing at the heights of parents and their children, and finding something that puzzled him deeply. We will follow him into that puzzle now. Chapter 7. Francis Galton, the restless measurer we met earlier, once set himself a simple-seeming question. Do very tall parents have very tall children? It sounds as though the answer must be an easy yes, and in a way it is, but the details held a surprise that unsaid untettled him and eventually taught the world something profound. He gathered the heights of many parents and the heights of their grown children, and he laid them side by side to see how one predicted the other. What he found was this: tall parents did tend to have tall children. Yes, but the children were, on average, a little less tall than their parents. Not shorter than people in general, but shorter than you would guess if you simply expected them to match their unusually tall parents. And the very short parents had children who were, on average, a little taller than themselves. The children of the extremes were drifting, gently, back toward the middle of everyone. The giant's children were still tall, but a step closer to ordinary. The smallest parent's children were still small, but a step closer to ordinary too. Something was quietly pulling the next generation toward the center. Galton first thought he had discovered some force in inheritance, some tendency of nature to pull the family back toward a typical human form. He called it regression toward the average, and the name has stayed with us, though what he had actually found was deeper and stranger than a force in biology. It is a truth about measurement itself, about any two things that are linked but not perfectly linked, and it appears far beyond questions of height. Here is the gentle heart of it. Whenever you measure something that is part real, steady quality, and part passing luck, the most extreme cases you find are almost always extreme, partly by genuine merit and partly by a fortunate roll of the dice. The tallest parents are tall for solid reasons, but they are also, very slightly, the ones for whom every small chance happened to point upward at once. Their children inherit the solid reasons, but not the lucky roll, because luck does not pass down. So the children keep the real part and lose the fortunate accident, and they land a little closer to the middle. It is not a force pulling them home. It is simply that the extreme was never entirely earned, the first place, and the unearned portion does not repeat. Once you see this, you begin to notice it everywhere, quietly at work in ordinary life. The student who scores the very highest on one test tends to score a little lower on the next, not because they have grown lazy, but because their highest score caught them on a day when everything happened to go right, and such days do not reliably repeat. The team that has its best season ever tends to do a little worse the following year. The patient whose symptoms are at their very worst on the day they finally try a remedy tends to feel better afterward, no matter what the remedy was, because they came to it at their lowest point, and the lowest point drifts back toward the ordinary on its own. That last example carries a gentle warning worth remembering. People often try a new remedy precisely when they feel worst at the extreme, and afterward they usually feel better, because the extreme fades on its own back toward their normal state. It is terribly easy to give the credit to the remedy, when much of the improvement was simply the natural drift back toward the middle that would have happened anyway. This is one of the quiet reasons that careful testing exists, so that this soft illusion does not fool us into trusting things that do nothing. Regression toward the average is not a trick played on us by the world. It is simply the world being honest about how much of any extreme was luck and how little of that luck endures. You may feel there is something almost consoling in this idea, and I think there is. A very bad day, an unusually low point, is by its nature partly a matter of many small misfortunes lining up at once, and such alignments are rare, which is exactly why the day was so low. Tomorrow, in all likelihood, those small chances will scatter again, and things will drift back toward your ordinary middle, gently, without your having to force them. The extremes of life, the highest highs and the lowest lows, tend not to be where we live. They are excursions, and the quiet gravity of the average keeps drawing us home from them. Let that be a soft thought to rest against tonight. Whatever was hardest about today, part of it was simply the unlucky lining up of small things, and small things rarely stay lined up for long. You do not have to do anything to return toward your center. The returning is built into the very nature of things. Let your body grow heavy with that reassurance. Let the day's extremes loosen their grip. Galton, following this thread, did something else of lasting importance. In studying how the heights of parents and children were related, he began to measure the strength of that relationship with a single number. How tightly, he asked, does one thing move with another? When parents are taller than average, how reliably are their children taller than average too? He was reaching toward a way of putting a number on the togetherness of two different measurements, a number that would capture, in one figure, whether two things rose and fell in step, or drifted independently, or moved in opposite directions. That number would become one of the most used and most misused ideas in all of statistics. It lets us ask whether hours of sleep move with health, whether education moves with income, whether one thing in the world seems to travel alongside another. It is a way of listening for the harmony or the discord between two sets of measurements. Galton sketched its beginnings, and a devoted student of his would soon give it its full and rigorous form, and a name that has stuck to it ever since. But this tool, useful as it is, carries a temptation folded inside it, one that has misled clever people for well over a century and still misleads us daily. When two things move together, it is desperately tempting to conclude that one of them must be causing the other. And sometimes that is true. But very often it is not true at all, and the trap is so natural, so easy to fall into, that learning to step around it is one of the most valuable habits a thoughtful person can develop. That trap, and how to hold it gently and wisely, is where we go next. Chapter 8. The devoted student who took Galton's idea and gave it its full form was an Englishman named Carl Pearson, working around the turn of the 20th century. He was fierce, brilliant, and tireless, and he built much of the machinery that a modern person would recognize as statistics. Among the tools he sharpened was the one Galton had only sketched, the single number that measures how strongly two things move together. We call it correlation, and it is worth understanding gently because it is one of the ideas you meet most often in daily life, usually without anyone naming it. Picture correlation as a number that lives between two extremes. At one end, two things move in perfect step. Whenever one rises, the other rises exactly in proportion, the way the height of a candle's shadow rises as the flame burns lower. At the other end, two things move in perfect opposition. Whenever one rises, the other falls in equal measure, like two ends of a seesaw, and in the vast middle sits the value that means no reliable relationship at all, where knowing one thing tells you nothing about the other. The way the color of your front door tells you nothing about the weather. Real relationships in the world almost always live somewhere in between, a loose leaning rather than a rigid link. Taller people tend to weigh more, but not perfectly. Warmer days tend to sell more cold drinks, but not without exception. Correlation is a way of measuring the strength of that lean. There is a real beauty in being able to capture, in a single figure, whether two great columns of measurements rise and fall together. It let people begin to ask precise questions about the tangled connections in the world. Does more schooling go along with longer life? Does one economic measure travel with another? The number gave a calm, steady answer where before there had only been impressions and hunches. Pearson and his contemporaries built a whole science on it, and it remains, to this day, one of the first things anyone reaches for when they want to know whether two things in the world are related. But here we arrive at the temptation I promised you, the one folded quietly inside this useful tool. When two things move together, the mind leaps, almost helplessly, to the conclusion that one must be causing the other. It is one of the most natural leaps we make, and it is wrong far more often than we would like to believe. Two things can move together for reasons that have nothing to do with either one causing the other, and learning to feel the difference is one of the gentlest and most important habits of clear thinking. Consider a simple, almost comical example. Across the warm months, the amount of ice cream that people eat rises, and, at the very same time, the number of people who get sunburned rises too. These two things move together beautifully. Their correlation is strong. And yet, no sensible person believes that eating ice cream causes sunburn, or that getting sunburned makes people crave ice cream. Something else is quietly driving both of them at once: the sun. On hot, bright days, people eat more ice cream and also spend more time in the sun and so burn more often. The ice cream and the sunburn are not linked to each other by cause at all. They are two children of the same parent, the summer sun, moving in step only because they share a hidden common cause. This is the heart of the matter, and it is worth saying softly and plainly. Correlation is not causation. When two things move together, there are always several possible stories. Perhaps the first truly does cause the second. Perhaps the second causes the first, with the arrow pointing the opposite way from what you assumed. Perhaps some third thing, lurking out of sight, causes both, as the sun caused both the ice cream and the sunburn. Or perhaps, in a world full of numbers, the two simply lined up together by sheer chance, the way two strangers might happen to wear the same coat. The correlation alone cannot tell you which story is true. It can only tell you that the two things travel together. Deciding why they travel together is a separate and much harder task. You might think this is a subtle academic point, but it shapes the world you live in constantly. Nearly every day, someone reports that people who do one thing tend to have some other quality, and the report quietly invites you to assume the first thing causes the second. Sometimes it does. Often it does not. And the truth is some hidden third factor connecting them, or an arrow pointing the other way. Learning to pause gently and ask what else might explain two things moving together is one of the quiet superpowers that statistics offers to an ordinary mind. It does not make you cynical. It makes you calm and careful and harder to mislead. Rest for a moment now and let this settle without effort. You do not need to become suspicious of everything. You only need to hold, softly, the knowledge that things moving together is the beginning of a question, not the end of one. Let your breathing lengthen. Let the small worries of the day loosen their hold, the way a knot loosens when you stop pulling on it. So how, then, do careful people ever find out whether one thing truly causes another, when correlation alone cannot say? This is one of the great questions, and the answer, developed over the last century, is one of the most quietly heroic ideas in the whole subject. Rather than merely watching the world and noticing what moves together, you deliberately intervene. You take a group and you split it, as fairly and as randomly as you can, into those who will receive some treatment and those who will not, so that the two halves are alike in every other way. Then, if a difference appears between them, you have real reason to believe the treatment caused it, because you have ruled out the hidden third factors by making both groups the same in every other respect. This deliberate splitting, this careful experiment, is how we cut through the fog of mere correlation to something closer to genuine cause. That way of thinking, of testing rather than only observing, brings us to one of the warmest and most human corners of the whole story. Because the person who did more than almost anyone to shape how such tests are done was not working in a grand laboratory. He was working, at least for a while, in a brewery, trying to make better beer and quietly inventing tools that would change how the world understands evidence. And near him, in a garden, a woman would make a claim about a cup of tea that led to one of the most famous small experiments ever imagined. We will pour that cup next. Chapter 9. On an afternoon in an English garden, sometime in the years between the two world wars, a small group of colleagues were taking tea. One of the women present remarked that she could tell, just by tasting, whether the milk had been poured into the cup before the tea or the tea before the milk. Some at the table smiled at the idea. Surely the order could make no difference to the taste, and surely no one could tell the two apart. But one of the men present did not smile and dismiss it. He grew genuinely curious, and he asked the truest question of all. How could we find out? How could we actually test whether she can do what she says? That man was Ronald Aylmer Fisher, and he became one of the most important figures in the entire history of statistics. What he saw in that small tea time moment was a doorway into a much larger question. How do you ever tell a real ability, a real effect, a real difference in the world, apart from mere lucky guessing? The lady claimed a genuine skill, but even someone with no skill at all, guessing blindly, would sometimes be right by chance. If you gave her a single cup and she named the order correctly, that would prove nothing, because a coin flip guess would land correctly half the time. So how many cups, and arranged how, would it take before her success became too consistent to be luck? Fisher's answer was to design the tasting with care. Prepare several cups, some made one way and some the other, and present them to her in an order she cannot predict. Then, look at how many she gets right, and, crucially, ask a precise question. If she truly had no ability and were only guessing, how likely would it be for her to do at least this well by pure chance alone? If the answer is that blind guessing would almost never do so well, then you have real reason to believe something more than luck is at work. If, on the other hand, a lucky guesser would often score as high as she did, then her result, however pleasing, proves nothing. This is the quiet, careful heart of what people call significance. It is not a grand or mystical idea, though it is often dressed up in intimidating language. At its center is a humble and honest question. Could what I am seeing have happened just by chance? You assume, for the sake of argument, that there is no real effect, that it is all luck, and then you ask how surprising your actual result would be in that world of pure luck. If your result would be very surprising under nothing but chance, you begin to suspect that something real is going on. If your result would be quite ordinary under pure chance, you hold back and you do not claim a discovery. It is a discipline of doubt, a way of protecting yourself from being fooled by the patterns that luck alone will always scatter in front of you. There is a deep gentleness in this way of thinking once you feel it. It is a kind of intellectual humility built right into the method. Before you allow yourself to believe you have found something, you first ask, seriously and fairly, whether you might be fooling yourself. You give chance its day in court. Only when the evidence would be genuinely surprising, under nothing but luck, do you let yourself lean toward belief. In a world that so often rushes to conclusions, there is something restful about a method whose first move is to slow down and ask, quietly, could this just be chance? Let that quality settle over you tonight. You do not have to decide anything, or conclude anything, or be certain of anything. You are allowed simply to rest in the not yet knowing, the way this careful method rests there before it speaks. Let your thoughts grow slow and unhurried. There is no result you must reach before morning. Not far from Fisher, in the years just before, another man had been wrestling with a closely related problem, and he had been doing it inside a brewery. His name was William Seeley Gossett, and he worked for a famous Irish brewer of dark beer, tasked with bringing scientific care to the making of it. The trouble he faced was that he could almost never gather large numbers of measurements. He could not test thousands of batches of barley or thousands of vats. He often had only a handful, a small and precious few, and he needed to draw trustworthy conclusions from them all the same. The tidy laws that worked so beautifully for enormous piles of numbers behaved differently when you had only a small sample in your hands. So, Gossett worked out the mathematics of small samples, how much you can and cannot trust a conclusion drawn from just a few measurements, how much wider your uncertainty must be when your evidence is thin. His employer, wary of letting rivals know that careful mathematics was being used to brew beer, did not allow him to publish under his own name. So he published under a quiet pen name, calling himself simply Student. And so, one of the most useful tools in all of statistics, still taught everywhere today, carries the modest name of a man who was not allowed to sign his own work. There is something touching in that, a discovery of real importance, offered to the world under a borrowed and humble name. Together, these ideas gave people a way to reason honestly from limited evidence, to ask not only what their numbers seemed to show, but how much they were entitled to believe it, given how few numbers they had and how easily chance could mislead. This is the machinery that sits, mostly unseen, behind the testing of medicines, the judging of experiments, the careful weighing of nearly every claim that calls itself scientific. It began, in part, with a woman who said she could taste the difference in a cup of tea, and a man patient enough to take surgically and ask how to find out. Notice, though, what quietly runs beneath both the tea and the beer. In each case, someone is trying to learn about a great unseen whole from a small handful of pieces, a few cups standing in for the lady's true ability, a few batches standing in for all the beer that might ever be brewed. This is one of the largest ideas in the entire subject. The notion that a small, carefully chosen part can faithfully speak for a vast and unseen whole. How a mere spoonful can truly tell you about the whole pot, how a few thousand people can speak for a nation of millions, is a small marvel in its own right, and it is where we turn next. Chapter 10. When you make a large pot of soup and you want to know whether it needs more salt, you do not drink the whole pot. You stir it well, and you lift a single spoonful to your lips, and you trust that this one small taste tells you the truth about the entire pot. There is something almost miraculous hiding in that everyday act, and it is worth pausing over. How can one spoonful possibly speak for gallons of soup? The answer is the same answer that lets a few thousand people speak for a nation of millions, and it rests on one gentle and essential word: stir. The spoonful tells the truth only if the pot is well mixed. If you have stirred it thoroughly, then the little sample in your spoon is a fair miniature of the whole, carrying the same balance of salt and broth and everything else. But if you have not stirred, if the salt has all sunk to the bottom, then a spoonful from the top will lie to you, and a spoonful from the bottom will lie to you in the opposite direction. The magic is not really in the smallness of the sample. It is in the fairness of it, in whether every part of the whole had an equal chance of ending up in your spoon. This is the quiet secret at the center of all good sampling. A small sample can faithfully represent a vast whole, but only if it is drawn fairly, so that no part of the whole is favored over another. This is how a poll can survey a few thousand people and tell you, with real and measurable confidence, something about the opinions of an entire country. It seems at first impossible. How could asking so few speak for so many? But if those few are chosen fairly, so that every person in the country had an equal chance of being among them, then that small group is a well-stirred spoonful of the nation. The balance of views within it tends to mirror the balance of views across the whole, and the law of large numbers we met earlier quietly guarantees that the mirror grows more faithful as the sample grows. You do not need to taste the whole pot. You need only to stir it well and taste a fair spoonful. And here is a fact that surprises almost everyone when they first meet it. So let it come to you gently. What matters most for the accuracy of a poll is not what fraction of the whole you sample, but simply how many people you actually ask, provided they are chosen fairly. A fair sample of a few thousand can speak about a country of millions nearly as well as it could speak about a town of thousands. The size of the great unseen whole barely matters. It is the size of your fair spoonful that sets how much you can trust the taste. This is why the same modest number of well-chosen people can be used to understand a small city or an enormous nation with almost the same reliability. The pot may be vast, but a good spoonful is a good spoonful. Of course, everything depends on that fairness, and fairness is harder to achieve than it sounds. History is full of gentle cautionary tales about samples that were large but crooked, that gathered enormous numbers of people who were not a fair cross-section of the whole. Long ago, one famous attempt to predict an election gathered responses from a staggering number of people, far more than any careful poll would use, and yet it predicted the outcome completely wrong. The reason was that the people it reached were not a fair spoonful. They had been drawn from lists that quietly favored one kind of person over another, and so the sample, for all its size, was like tasting only the top of an unstirred pot. A smaller but fairer poll, taken at the same time, got the answer right. The lesson has echoed ever since. A fair small sample beats a crooked large one every time. Stirring matters more than volume. Ret here for a moment, and let the soup and the spoon stay with you as a soft picture. There is real comfort in how ordinary the idea is. You already trust a spoonful to speak for a pot every time you cook. The whole science of sampling is only that same everyday trust, made careful and given rules. You already understand it in your hands. Let that familiarity ease you. Let your breathing slow, and let the warmth of something as homely as a pot of soup carry you a little further toward sleep. There is one more gentle honesty that good sampling insists upon, and it is one of the finest habits in the whole subject. When careful people report what a sample tells them, they do not pretend to perfect certainty. They attach to their answer a quiet margin, a small acknowledgement of how much the true figure might wander from what the sample happened to show. They will say that the real number lies within a certain range, most likely, rather than claiming to know it exactly. That modest range is not a weakness in the method. It is the method being truthful about its own limits. It is a way of saying, here is what we found, and here is how sure we are allowed to be, no more and no less. There is a deep integrity in a form of knowledge that always tells you how much it does not know. This willingness to measure your own uncertainty and to state it plainly is one of the quiet gifts that statistics offers to a noisy world. It does not shout. It does not claim more than it has. It says, from a fair spoonful of the whole, here is the truth as best we can taste it, and here is the width of our doubt. In an age full of confident voices, there is something restful, almost soothing, about a discipline whose highest virtue is knowing and saying exactly how sure it is entitled to be. We have now watched statistics learn to test a claim honestly, and to let a small fair sample speak for an enormous whole. Both of these rest on gathering evidence and weighing it with care. But there is another, older and more personal question hiding beneath all of it, a question about belief itself. When a new piece of evidence arrives, how much should it change what you already thought? How do you fold fresh news gently into everything you believed before without either ignoring it or being swept entirely away by it? A modest country minister whose ideas were only published after his death left behind a way of thinking about exactly this, and it has quietly become one of the most beautiful ideas in the whole subject. We turn to him now. Chapter 11. There was, in 18th century England, a quiet minister and amateur mathematician named Thomas Bayes. He was not famous in his lifetime, and he published little. But among his papers found and shared by a friend after his death, was a short piece of reasoning about chance that would, 2 centuries later, come to feel like one of the deepest ideas anyone has ever had about how a mind should learn. It concerns something wonderfully ordinary: how you should change your mind when new evidence arrives. Think about how you actually come to believe things. You never start from nothing. You always begin with some sense, however rough, of how likely various possibilities are, drawn from everything you have seen before. Then something new happens, a fresh piece of evidence, and it nudges your belief. Not to certainty, usually, and not back to where you started, but to some new place in between. Bayes gave a precise and gentle account of exactly how far that nudge should carry you. His idea is often called updating, and it captures something we all do imperfectly and shows us how to do it with care. Here is the shape of it, in plain words. You begin with your prior sense of how likely something is, your honest starting belief, before the new evidence. Then the evidence arrives, and you ask a careful question. How well does this new evidence fit each of the possibilities I was considering? The possibilities that would have made this evidence likely grow more believable. The possibilities that would have made this evidence unlikely fade. And you settle into a new belief that blends what you thought before with what you have just learned. Strong prior belief resists being overturned by a single weak scrap of evidence, as it should. But surprising, weighty evidence can move even a firmly held belief, as it should. The updating balances the two, gently, according to their weights. There is a famous and important lesson hidden in this way of thinking, one that touches everyone's life, so let me offer it softly. Imagine a test for some rare condition, a test that is quite accurate, rarely wrong. You take it and it comes back positive. It is natural to feel that you almost certainly have the condition. But Bayes teaches us to pause and remember the prior, the fact that the condition was rare to begin with. When something is truly rare, the great mass of people who take the test do not have it, and even a small rate of false alarms among that enormous healthy group can produce more false positives than true ones. So, a single positive result on a test for a rare condition often means the chance you truly have it is far lower than the fear suggests. This is not a trick, and it is not false comfort. It is simply what happens when you fold the new evidence properly into what was true before. The rarity does not vanish just because one test spoke up. Sit with how reassuring that reasoning can be. It is a mathematical argument for not leaping to the worst conclusion from a single, frightening piece of news. It says, gently, remember everything you knew before this moment, and weigh the new thing against it, rather than letting the newest and loudest fact erase all the quiet context around it. This is not only how careful doctors ought to think, it is a soft and steadying way to move through an uncertain life, holding new worries against the fuller background of what you already know to be true. The person who did the most to develop this seed into a full and far-reaching method was not Bayes himself, who had died, but the great French mathematician Pierre-Simon Laplace, working a little later. Laplace, quite independently, arrived at the same way of reasoning, and extended it far beyond anything Bayes had imagined, using it to weigh evidence about the heavens, about the masses of the planets, about the very reliability of human testimony. In his hands, updating grew from a curiosity into a genuine engine for learning from data, and much of the modern spirit of the idea comes down to us through his work, rather than through the modest minister whose name it happens to carry. Let your thoughts rest a while now. There is nothing here to master, only a gentle picture to hold, a belief softly held, adjusting itself as evidence arrives, never lurching to certainty, never quite standing still, always settling toward a truer place. It is a peaceful image of a mind at ease, with not knowing everything at once, willing to be moved but not easily swept away. Let your own thoughts have that quality tonight, loosely held, unhurried, open. Let the day's certainties and doubts alike grow soft at the edges. What makes this way of thinking so beautiful is that it treats belief itself as something that lives on a scale, rather than as a simple yes or no. You are rarely fully certain of anything, and you rarely should be. Most of what you believe to a degree, more sure of some things, less sure of others, and new evidence slides those degrees gently up or down. This matches the texture of real life far better than the harsh world of perfect certainty and perfect doubt. You wake unsure whether it will rain, more inclined to think so when the sky's gray, less so when it clears, adjusting all day long as the clouds come and go. That constant, gentle updating is not a flaw in how you think. It is, when done with care, the very shape of wisdom. And so we have gathered, over these hours, a whole quiet toolkit for living with uncertainty, the average and the spread, to describe a crowd of numbers, the bell curve and the laws of chance to understand how things scatter and settle, the careful test and the fair sample to weigh evidence honestly. And now this gentle art of updating, of changing your mind by just the right amount when the world tells you something new. Each of these was a hard-won gift from a curious and patient person, offered across the centuries to anyone willing to receive it. But every one of these tools can be misused, and even the most honest of them can quietly mislead if you are not careful. Numbers do not lie, people sometimes say, and yet numbers can certainly be arranged to tell a story that is not quite true, often without anyone meaning to deceive at all. There is a particular and famous way this can happen. A gentle paradox where the very same numbers seem to say opposite things, depending on how you group them. Understanding it is one of the finest protections a thoughtful person can carry, and we will look at it softly next. Chapter 12. Let me tell you about one of the gentlest surprises in all of statistics, a puzzle so quietly strange that it fools even careful people the first several times they meet it. It carries the name of a British thinker named Edward Hugh Simpson, who described it clearly in the middle of the 20th century, though others had glimpsed it before him. The heart of it is this: it is entirely possible for a pattern to appear in every single group of your data, and yet for the opposite pattern to appear when you pour all the groups together into one. The parts can say one thing, and the whole can say the reverse, and both can be perfectly, honestly true at once. That sounds impossible when you first hear it. So let me walk you through it slowly and softly with a made-up example built only to show the shape of the thing. Imagine two doctors, and imagine you are trying to decide which one is better at treating a certain illness. The first doctor treats mostly people who are only mildly ill and cures a great many of them. The second doctor treats mostly the gravely ill, the hardest cases, and cures a smaller share of them. If you simply look at the overall fraction of patients each one cures, the first doctor looks clearly better because so many of their patients were easy cases to begin with. But now look more carefully and split the patients by how sick they were. Among the mildly ill, it turns out the second doctor actually cures a higher fraction than the first. And among the gravely ill, the second doctor again cures a higher fraction than the first. In every group of patients, mild or grave, the second doctor does better. And yet, when you lump everyone together, the second doctor's overall numbers look worse, purely because they took on so many of the hardest cases. The second doctor is better with every kind of patient and looks worse overall. Both statements come from the very same numbers, and both are true. The trick lies in the hidden grouping, in the fact that the two doctors were not treating the same mix of patients. The gravely ill drag down anyone's overall cure rate, and the second doctor simply had far more of them. When you average across the groups without accounting for how unevenly the patients were divided, the difference in the mix quietly overwhelms the difference in skill, and the overall number tells a story that is, in a deep sense, backwards. This is the paradox that carries Edward Hugh Simpson's name. It is not a rare freak of arithmetic. It hides in real data about medicine, about schools, about wages, about almost anything where the groups you are combining are of different sizes and different natures. You might expect this to feel unsettling, but I would gently offer you the opposite. This paradox is not evidence that numbers are untrustworthy or that truth is hopeless. It is an invitation to look a little closer, to ask what groups are being combined and whether they are truly alike. The numbers were never lying. They were simply answering a slightly different question than the one you thought you were asking. The overall figure answers, what happens if you mix all these different people together? The grouped figures answer, what happens within each kind of person on its own? Those are genuinely different questions, and it is no paradox at all that they can have different answers. The confusion comes only from expecting one number to answer both at once. The quiet wisdom to carry away from this is a soft habit of curiosity. Whenever someone shows you a single sweeping number about two groups, a gentle voice in the back of your mind can ask, are these groups really comparable? Or is something hidden in how they are mixed? Were the two doctors treating the same kinds of patients? Are the two schools teaching the same kinds of students? Is the comparison fair underneath, or is the difference in the mix doing the talking? You do not have to become distrustful. You only have to stay curious, to remember that a number always summarizes a story, and that it is worth asking, gently, what story it left out. Rest here for a moment. There is no test coming, no conclusion you must reach. You are simply learning to hold numbers the way you might hold a smooth stone, turning it over, looking at more than one side. Let that unhurried curiosity be a restful thing rather than a worried one. Let your body sink a little deeper into the warmth of the bed. The world will still be full of numbers in the morning, and you will meet them a little more wisely. And none of that requires anything of you now. This is really the mature heart of the whole subject, the part that separates true understanding from mere calculation. It is not enough to compute an average or a correlation or a cure rate. You have to ask what lies beneath it, what was grouped and what was hidden, what question the number is truly answering. The finest people who work with data are not the ones who can calculate the fastest. They are the ones who stay curious about where the numbers came from, who ask what is being compared with what, who remember that behind every tidy figure is a messy human world that the figure only partly captures. This is a form of honesty as much as a form of skill, and that honesty is a kind of gift you can carry into your own life, far from any laboratory or spreadsheet. The next time you are told that one thing is better than another, or that some group differs from some other, you can hold it lightly and ask the soft questions. Compared to what? Grouped how? What might be hidden in the mixing? This is not cynicism. Cynicism refuses to believe anything. This is something warmer and more useful, a patient willingness to understand before concluding, to look for the fuller picture before letting a single number decide. It is, in the end, a kind of gentleness toward the truth. We have spent these hours in the deep history and inner workings of the subject, among gamblers and ministers and brewers and careful measurers of tea. But all of this patient thinking was never meant to stay locked in books. It flows out quietly into nearly every corner of the life you are resting in tonight, shaping things you rarely think to connect to a shopkeeper counting London's dead or two friends trading letters about a game. In the next stretch of our night together, we will step out of the history and look softly at how all of this surrounds you right now in the ordinary world just beyond your pillow. Chapter 13. Let us step out of the old letters and dusty tables now and look softly at the world around you tonight, because the quiet ideas we have gathered are woven through nearly all of it. You may never have thought of yourself as living inside statistics, and yet you do, gently. All day long, it is in the weather you checked. This morning, in the medicine in your cabinet, in the safety of the food you ate, in the very screens that carry these words to you. A whole invisible scaffolding of careful counting holds up the ordinary comfort of a modern day. Begin with something as small as the forecast. When the forecast tells you there is a 30% chance of rain tomorrow, it is easy to feel that this is a vague and slippery thing to say, neither a yes nor a no, but it is actually a precise and honest statement, and it comes straight from the ideas we have followed tonight. It means, roughly, that on a great many past days that looked just like tomorrow looks now, rain fell on about 3 out of every 10 of them. The forecaster is not dodging the question. They are being truthful about uncertainty, giving you a fair sense of the odds rather than a false promise of certainty. A 30% chance is an invitation to carry an umbrella just in case, and to be neither surprised by rain nor cheated by clear skies. It is the law of the long run, spoken softly into your morning. The medicine in your cabinet reaches you through the same careful thinking, only far more of it. Before a new remedy is allowed to be given to people, it passes through exactly the kind of deliberate testing we spoke of earlier, the careful splitting of people into groups as alike as possible, so that the true effect of the treatment can be separated from mere hope and mere chance, and the gentle drift back toward health that happens on its own. Every step of that testing leans on significance, on sampling, on the honest weighing of evidence against the possibility of luck. When you take something to ease a pain or fight an illness, you are quietly trusting a chain of reasoning that runs all the way back to a woman tasting tea in a garden and a man working out the mathematics of small samples in a brewery. The comfort in your hand rests on their patience. Rest for a moment on that thought, because there is something warm in it. The care of countless careful strangers, stretching back through the centuries, is folded silently into the smallest conveniences of your evening. You are held in ways you never see by other people's devotion to getting the numbers right. Let that be a soft and companionable feeling as you lie there. You are not as alone in the dark as the quiet might suggest. A great deal of gentle, patient work stands between you and harm, and most of it you will never have to think about at all. Consider, too, the things you buy and use and the quiet counting that keeps them trustworthy. On the production lines that make everything from light bulbs to jars of food, no one tests every single item, for that would be impossible. Instead, they draw a fair sample, a spoonful from the great pot of production, and from that sample they judge the health of the whole. If the sample shows too many faults, they know something has gone wrong upstream, long before a flawed product reaches your home. This gentle guardianship, called quality control, is sampling, and the law of large numbers put to work in the service of ordinary reliability, so that the things in your kitchen simply work night after night, without your ever wondering why. Even the screens and services that fill a modern day are steeped in this same thinking, though it hides itself well. When two versions of a page or a message are quietly compared to see which one people prefer, that is a small experiment, a testing of one thing against another. The tea tasting scaled up to millions of gentle cups. When a service seems to anticipate what you might like, it is leaning on correlations, on the patterns of what tends to go with what, holding them loosely, updating them as new evidence arrives, in a distant echo of the minister's idea about changing one's mind. The whole quiet intelligence of the modern world is stitched together from the very threads we have been following all night, and there is one more place these ideas live, closer to home than any factory or forecast. They live in you in the way your own mind already works, imperfectly, without any training. You are constantly gathering samples of the world and guessing at the whole. You are constantly noticing what goes with what, and updating your beliefs as new things happen, and drifting back toward your ordinary self after the highs and lows of a hard day. The great thinkers we have met did not invent these habits of mind out of nothing. They noticed what human beings already do, roughly and instinctively, and they made it careful and honest and precise. In a real sense, the whole subject is a portrait of the human mind trying to understand an uncertain world, drawn slowly and lovingly over 400 years. That is perhaps the most reassuring thing of all. Statistics is not a cold and foreign machinery bolted onto life from the outside. It is the natural way a curious mind reaches toward truth. Cleaned up and made trustworthy, you have been doing a rough and ready version of it your whole life. Every time you tasted a spoonful and trusted it, every time a single frightening rumor failed to overturn everything you knew, every time you sensed that a run of bad luck would probably not last, the centuries of careful work simply gave names and rules to instincts you already carry. Let that dissolve any last sense that this is a subject for other people, for experts in distant rooms. It is quietly about you and about the gentle way you already make sense of things. We have come a long way tonight, from a jar of coins on a table to the medicine in your cabinet and the weather beyond your window. We have watched counting grow into a science, and chance become measurable, and belief learn to update itself with grace. There remains only the last and softest part of our journey, where we gather everything together and ask what all of it has really been for. Not the calculations, but the quiet wisdom beneath them, the way this long human effort can help a person rest more easily inside a world that can never be fully known. That is where we will end, gently, and where I will finally wish you good night. Chapter 14. So what has all of this really been for? We have wandered through 400 years of patient thinking, past shopkeepers and ministers and brewers, past coins and dice and cups of tea, past bell curves and fair samples and gently updated beliefs. It would be easy to think of statistics as a box of clever techniques, and it is that. But underneath the techniques lies something quieter and more human, and it is the thing worth carrying with you into sleep tonight. At its heart, this whole long effort has been about one thing: learning to live wisely and calmly inside a world we can never fully know. Think about how much of life is uncertain. You cannot know what tomorrow holds, or how a choice will turn out, or which of your small worries will amount to anything. For most of human history, this uncertainty was simply endured, or handed over to fate, or feared. What all these curious people slowly built was a different way to meet it, not a way to abolish uncertainty, for that can never be done, but a way to measure it, to hold it in your hands and see its shape, to say how likely and how unlikely things are, and to make good decisions even without knowing for sure. That is a gentler relationship with the unknown than fear, and a wiser one than false certainty. Notice the quiet humility that runs through everything we have touched. The average admits that no single number can capture a crowd, so it offers only a fair center. The spread admits that things vary, and measures the variation honestly rather than pretending it away. The careful test begins by doubting itself, by asking whether what it sees could be mere chance. The fair sample states plainly how much it does not know, attaching its modest margin to every answer. The art of updating never leaps to certainty, but moves belief by just the right amount and no more. In every case, the deepest wisdom is not a grand claim to know, but an honest reckoning with the limits of knowing. There is something deeply peaceful in that, something you can rest against. Let your body settle fully, now as we draw near the end. Let the last of the day's tension flow out of your shoulders, out of your jaw, out of your hands. You have followed a long and winding path tonight, and there is nothing left to hold. Every idea we gathered will keep its shape without you. The averages will still center. The curves will still rise and fall. The long run will still settle toward its patient truth, whether or not you remember a single word of it in the morning. You are free to let all of it go. There is a real comfort, I think, in the largest lesson of the law of large numbers, and it is worth taking with you into the dark. The single moment is wild and unknowable, but the great sweep of many moments is steady and kind. Your own life is like that. A single hard day, a single stroke of bad luck, a single worry, looming large in the quiet of night. These are the wild single tosses, and they cannot be predicted or controlled. But across the long run of your days, things settle. The extremes drift back toward the middle. The lowest points, which are always partly just the unlucky lining up of small things, come apart again on their own. You do not have to force your way back to steadiness. Like the tossed coin in its level, you tend toward it naturally, given a little time. And there is comfort, too, in how much gentle care surrounds you without your ever seeing it. The forecast that prepares you for rain, the medicine tested with such patience, the countless small counts that keep the ordinary world reliable. All of it is the quiet legacy of people who loved getting the truth right. When John Grount bent over his old paper bills of mortality, he was trying, in his way, to protect the living. When Florence Nightingale drew her diagrams of preventable death, she was trying to save soldiers no one else was counting. That tender impulse to understand the world well enough to care for the people in it has run through this whole story from its very first day. You are one of the people it has always been trying to care for. So if you take anything from this long, slow night, let it be this soft and simple thing. Uncertainty is not something to fear. It is the ordinary weather of being alive, and human beings have spent centuries learning to walk through it with grace. You do not need to know how tomorrow will unfold in order to rest tonight. You only need to trust, as all these patient thinkers came to trust, that the world has a shape beneath its surprises, that the long run is gentler than any single moment, and that not knowing everything is not the same as being lost. It is simply the condition of a mind meeting a large and living world, and it is nothing to be afraid of. Let your breathing grow slow and, even now, like the fraction of heads settling toward its calm, 1/2. Let your thoughts drift and scatter the way measurements scatter softly around their center, each one finding its place in a shape you do not have to arrange. There is no problem left to solve, no number left to check, no certainty you must reach before you are allowed to rest. You have done enough today. You have understood enough tonight. You are allowed now to simply let go. The people we met tonight are all long gone, their letters yellowed, their notebooks closed. But the quiet order they uncovered is still here, holding steady all around you in the settling of chance and the shape of the scatter and the gentle return of things toward their center. It asks nothing of you. It simply keeps its patient promises the same, tonight as it was in a plague-shadowed London or a garden with a cooling cup of tea. You can lean your whole weight against that steadiness and let it hold you. Rest now. Let the numbers keep each other company in the dark, the way they always have, without any need of you. Let the long run carry you gently on toward morning. The world will still be here, still faithfully countable, still full of its quiet order when you wake. And until then, there is nothing you need to do but breathe and soften and sleep good night.